Hello and welcome to our series of videos about index laws. This video here is there to give you an idea and just give you a generalization of what the index laws are before we go into more detail. So when we start here, index laws, laws of indices, laws of exponents, laws of powers, power laws, whatever, lots of different names. Basically, we've got a base, which is our number at the bottom, then we've got a power, which is what it's being raised to. That can be called an index, can be called an exponent, whatever the case may be. And then we've got 6 laws. 2, 3, 4, 5, 6, 7. Oh no, we've got 8 actually. Anyhow, doesn't matter what they are and how they're called. First one is about when we multiply the same numbers of the same base. So we might do a to the power of 3 times a to the power of 4, and from there if we're multiplying, then we add the two powers. So we'll have a 3 plus 4 is 7. Now similarly, if we're dividing, a to the power of 5 divided by a to the power of 2, we've got the one side here, we've got its inverse or its opposite there. Opposite of addition is subtraction, so this becomes a 5 minus 2, which is 3. The third thing here that we've got is if we've got a, and then we've got, and we have that to a power m, whatever that may be. So we've got a to the power of m, we'll do a to the power of 2, and then we'll make that all to the power of 3. What we end up doing is we end up multiplying these two numbers. So this will become a to the power of 6. Now, similarly, if we've got a, and then we've got b, and then we've got, say, a 4 here, that essentially is a to the power of 1 and b to the power of 1. Now, just like what we did here, where we multiplied the two powers, we're going to do that here. So we're going to have 4 times 1 and then 4 times the other one. So this ends up being a, 1 times 4 is 4, and b, 1 times 4 is also 4. So then in a different context, we could have x to the power of 2 and b to the power of 5. We could put that all to the power of 3. So over here, 3 times 2 for x, so x equals 3 times 2, which is 6, and 3 times b to the power of 5, which ends up being b to the power of 15. So that's what we end up with there. Same kind of thing if we're dividing. So the next law here that we're looking at is this one here. It's got to do with division. So if we have a over b all to the power of 3, that becomes a to the power of 3 over b to the power of 3. Because what are our powers here? They are 1s. So, in the same vein, if we had x to the power of 2 over b to the power of 3, put that all to the power of 4, we'll end up with x 2 times 4, which is 8, over 4 times 3, b to the power of 12. Now, the next one here is anything to the power of 0. It doesn't matter what it is, it's always going to be 1. So we can have x to the power of 0 will be 1. We can have 5 to the power of 0. That's also going to be 1. Where you've got to be careful though is if they do something like 3x to the power of 0. That is actually 3 times x to the power of 0, which we know is 1. So that ends up being 3. Sometimes I'll try and be a little bit swifty, but we'll have a look at that later on. For the last couple here, this has to do with our negative power. So as soon as we've got a negative power, it becomes a reciprocal, and that power becomes positive. So if we had something like a to the power of negative 3, let's do a line here just to differentiate things, that becomes 1 over a to the power of 3. So it doesn't matter what it is, that's what we end up with. We could have 2x to the power of negative 4. That will become 2 times 1 over x to the power of 4. So we end up with 2 over x to the power of 4. Okay, we've got one more, and I'm running out of space here. Just going to move this stuff, and I'll move this stuff, and I'll move this stuff. That should be enough room for the bottom one. Okay, for our last one, we're going to do that as well. For our last one, we're dealing with fractional powers. So what that's telling us is if we've got a fraction, whatever the denominator is, whatever the numerator is, that goes to the power. Whatever our denominator is, goes outside the root. So we could have a to the power of 1 over 2. That ends up becoming the square root of a to the power of 1 with a 2 there. If we had x to the power of 3 over 4, well then that is the equivalent of the square root. We've got 4 as our denominator, so it's the 4th root of x cubed. So that's what we've got. There. So that's basically our laws of indices, and that's kind of what we have to know.